Hello, welcome to the second video for ions, and this is homework help. So this is not required, but if you're struggling, I'm going to walk through some of the homework problems. I'm not going to do them all, but I'm going to do a couple of from each section to show you what I'm looking for. Now, first section follows the notes really well. So I'm only going to do one from here, and I'll just start with beryllium. So you have been tasked with drawing the Bohr model ion formation, and I've given you a shell outline. Now, beryllium is element 4, so it has 4 protons. It has an atomic mass of 9, which means it has 5 neutrons. We should be really good at that. Now, we always start with the atom first. So neutral atom contains equal amounts of protons and electrons. So beryllium starts with 4 protons, so therefore it starts with 4 electrons. 2 in the first shell and 2 in the second shell. Now, my outline just provides 4 shells all the way down, so you don't necessarily have to fill them. It's there to help a little bit with not having to draw the outline every single time. Okay, now, path of least resistance. Shell 2 can either lose 2 or gain 6. Much faster to lose 2. Then, draw your ion. Now, I started with 4 protons and 5 neutrons. Never going to change that nucleus. But my electrons started with 4, lost 2. Now I'm down to 2. Now, remember, losing 2 is really losing 2 negative charges. So minus 2 is an ion with a plus 2 charge. If you want to see that in the other form, I have 4 positives over here, 2 negatives, so my net charge is plus 2. Lots of different ways to think about it. Minus 2. You can do it in your head, or you can show the charge outline. But I'm looking for the nucleus, the correct number of electrons, and then the correct charge depicted. So this would be an ion formation pathway for beryllium. Now, this is a good time to remember an octet is usually 8 electrons, but this first shell is filled with only 2. So even though we're not at 8, we still are meeting the full shell rule because that first shell is so tiny. The other 3 look exactly like that first example. Draw the standard atom, draw the change, and then draw the final product and include that charge. Okay, if you want to pause the video and complete those other 3, you can go ahead and do that. Okay, section 2 is the shortcut. So same thing except for now you can do the ion shortcut. We'll go ahead and do 2. We'll do germanium and we'll do potassium since it's first. Okay, potassium. First thing, you got to find it on the table. Potassium. Column 1, 1 dot, 1 valence electron. Now, draw the pathway. Model the change. So I'm either going to lose 1 or find 7. Losing 1 is easier. And then I'm going to become potassium plus 1 because I lost a negative 1 charge. And remember, you can always double check this. I wrote the shortcut on here. Potassium should become a plus 1. I draw us losing negative 1, potassium plus 1. I am good. Okay. Now, germanium is one of our funky ones. First step is to find it on the table. Germanium is in column 4, so it has 4 valence electrons. Okay, now 4 is my OR pathway. I don't care which you pick, but your arrow and your change has to match your product. I'm going to go ahead and show both, just so we have an example of a plus and a minus ion. Now, most of you will probably pick lose because it means fewer work at the end. If I draw germanium losing 4 electrons, I should have a final ion charge of plus 4 because we minus 4. Now, if I drew germanium gaining 4 electrons, I need to have 2 things. Anytime I'm gaining electrons, I need to show them in my final ion. So started at 4, gained 4, have 8, and then I also need to represent my charge correctly. This is germanium minus 4. You cannot put plus minus 4. The charge you put needs to match the pathway that you chose. Okay. That's it for this page, except for that tiny little short answer on the bottom. Now, you will see this question like 3 times throughout the packet. It's probably on your test. Some of you will probably still get it wrong. Why don't noble gases form ions? I'm not going to give you the answer. I'm going to give you a hint. Noble gases is the name for column 8. So you need to look in your notes and figure out why doesn't column 8 form an ion. Okay. So if you want to pause the video at this time and complete the back of sheet 6, you can go ahead and do that. Okay. Sheet 7, the real reason I thought we needed, or potentially would need, a video lesson on how to do it. So sheet 7, you see a notation that you haven't seen before. It's not my favorite, but it is a very common way to be assessed on ions and isotopes. So we're seeing a couple of vocab words mixed in here. Ions and isotopes. Now, just to remember, an isotope notation is the element name with a number, like 134. An ion notation is an element name with a charge, +3, -3. The charge is going to be a superscript, so tall and tiny, and the isotope notation is going to be standard font. Okay. Now, we can see here, oxygen -2. Anytime I have a plus or a minus, I know I'm working with an ion. First step, find oxygen on the periodic table. I think I can fit both in here. Okay. Oxygen is element 8, which means it has 8 protons. It has an atomic mass of 15.99. This is an ion question, so I'm just going to take that atomic mass and round it to 16, which means I have 8 neutrons. Now, electrons. This is oxygen ion. Oxygen -2. I have a net charge of -2. Couple of ways to think about this. I'm going to start with the simplest. Neutral oxygen has equal number of pluses and minuses. So I had 8 electrons and 8 protons to begin with. This oxygen ion has 2 extra negatives. So if I have my neutralized, and then my 2 shown, I can see, oh, I have 10 electrons. That's one way to get to an answer. You can also think about that in your head. I have 8 positives, I need 2 more negatives, therefore I need 10 electrons. But that's what this page is asking you to do. Given the symbol, you should be able to fill out all of the subatomic particle information for that atom. Okay. Now, this can be a little tricky at first. You'll get there. Let's look at B now. Lead 206. Now, there's no plus or minus, there's no superscript. This is an isotope notation. Anytime you're given an isotope notation, the mass is provided. So you don't use the periodic table mass, you're going to use the mass that is shown in the prompt. So my mass here is 206. The rest of it is same standard thing we've been doing. Find lead. Found it. Find lead. All right, lead is element 82. My neutrons, again, use the mass given. Don't use the 207. Use the mass given. I'm not doing that in my head. Below power. All right, so my mass is 206. 82 of those are protons. The remaining mass of 124 must be neutrons. Now, there was an instruction, assume all isotopes are neutral. So my positives in a neutral atom equal my negatives. So if I have 82 protons, I must also have 82 electrons. But this is how this page is to be done. Find the prompt, figure out if it's an ion or an isotope, follow the examples from there. Okay. Fairly straightforward, just be careful. Watch out for ions versus isotopes. Okay, short answer questions, just a couple of hints. Why don't noble gases? Again, that's column 8. Usually form ions, check your notes. Why do elements on the left side of the periodic table tend to form positive ions? Now, I haven't given this to you word for word. Look at your diagrams, see if you can see a pattern and explain that pattern. Why does the Lewis dot structure correlate to the ion formation pattern? And then on the back, more practice with these, just takes practice. And then a couple of more short answer questions. So, why might the alkali metals, which are column 1, and the halogens, which are column 7, be the most reactive? Now, I know I haven't taught you reactivity yet. I want you to look for how are column 1 and column 7 similar. Look for the similarities, and that similarity can drive your answer. All right. Good luck. Get your homework done, and when in doubt, do something. Don't leave with a blank paper. When in doubt, do something.